Welcome students to CALC Academy, where calculus is made easy just for you. In today's unit, we will be discussing about the applications of derivatives. But before that, let us define what is derivative. Derivatives can be approached in two different ways. The first one is the geometrical, or the slope of a curve, and the next one is the physical, which is the rate of change. But in today's unit, we will be focusing more on the geometrical, or the slope of a curve. So why do we need to study derivatives? We need to study derivatives because it is important in some aspects in our lives, and we can apply these learnings in our daily lives, for example, in business. Engineering, mathematicians, scientists uses derivatives in order for them to solve different problems because it helps them in calculating anything with respect to another event. So what mathematical skills are needed to solve antiderivative problems correctly and more efficiently? So the mathematical skills needed in solving antiderivatives are the critical thinking skills or the reasoning. The second one is the deep understanding of the concept, and the last one is the skills in solving derivatives or the proper use of differentiation rules as well as the applications of derivatives. So let us now begin. For our problem in this unit, we will find the slope and concavity of the curve y is equal to x to the 4th plus 2x squared plus 3x minus 1 at the point where x is equal to 2. Find the equation of the tangent line at that point. So in order for us to solve the slope of the curve, we will find the derivative of that curve. So given the equation, we will use the power rule as well as the constant rule. So in using the power rule, the curve will be 4x cubed plus 4x plus 3. 1 will be cancelled due to the constant rule, and then we will substitute 2 to the curve. So it will be 4 times 2 cubed plus 4 times 2 plus 3, which will be equal to 32 plus 8 plus 3. And our y prime, or our slope, will be equal to y prime is equal to 43. So for getting the concavity of the curve, we will be using the second derivative of the curve y is equal to x to the 4th plus 2x squared plus 3x minus 1, or the first derivative of our y prime, which is the 4x cubed plus 4x plus 3. So just like the other derivative process, we will use the power rule as well as the constant rule. So it would result to 12x squared plus 4, and we will substitute 2 to the x, so it will be 12 times 2 squared plus 4 is equal to 48 plus 4. So our concavity, or the y to the second prime, is equal to 52. So lastly, in getting the equation of the tangent line at that point, which is 2, first we need to find the value of y. So in getting the value of y, we will use the original equation, which is x to the 4th plus 2x squared plus 3x minus 1, and then we will substitute 2 to all of the x's, so it will be 2 raised to the 4th plus 2 times 2 squared plus 3 times 2 minus 1, so it will become 16 plus 8 plus 6 minus 1, so our y is equal to 29. So now, we can find the equation of the tangent line at that point using all of our given, which is x is equal to 2, y is equal to 29, and our slope is equal to 43. In finding the equation of the tangent line, we will be using the slope point form. So, the slope point form is equal to y minus y sub 1 equals to the slope multiplied by x minus x sub 1. So we will just substitute all of our given in the equation. So y minus 29 is equal to 43 multiplied by x minus 2. Now we will distribute 43 to x minus 2. So it will become 43x minus 86. And the 29 here, we will transpose it to the right side. So it will become plus 29. So we will combine the like terms. So our y is equal to 43x minus 57, which is the equation of the tangent line. So for the summary of the problem, the slope is equals to 43, the concavity is equals to 52, and the equation of the tangent line is equals to 43x minus 57. Thank you for watching, and I hope you understand the lessons. See you next time!